Section 1.3 is called cube roots. And if you write 2 to the power of 2, that's called 2 squared. You say that is 2 squared. Whereas if you put a 3 up here, which is 2 to the 3rd power, you would say that's 2 cubed. And just like a perfect square is some integer squared, a perfect cubed is some integer raised to the 3rd power, or some integer cubed. So we could take, now on the squared side, you could put in a positive integer and you're going to get a positive perfect square, because a positive times a positive makes a positive. Or you could put in a negative integer, and when you square it, that's a negative times a negative. So that's going to come out to be a positive. So perfect squares are always positive. Now if you cube it, if I have a positive integer and I cube it, of course it's positive. But if I have a negative integer, like -3 for example, and I cube it, that's going to come out to be negative. So perfect squares are always positive, but perfect cubes could be positive or negative. Let me show you. Let's take -2 for example, so you can see it. If I have -2 times -2 times -2, that's -2 cubed. That's going to be 2 times 2 times 2, which is 8, but a negative times a negative times a negative is going to make a negative, because anytime you have an odd number of negatives multiplied together, you're going to get a negative back out. Now this table, if you don't have notes, you need to copy this down. The first row are just integers. Just the first row is like the number line. Here's 0, then you have positive integers, and then you have negative integers. The second row are the squares of the integers. So 0 squared is 0, 1 squared is 1, 2 squared is 4, -3 squared is 9, and so on. And you see that the squared row, it's all positive. And then the last row are the cubes of the integers. So if we look at 0, 0 cubed is still 0. 1 cubed is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed is 3 times 3 times 3, 27. Now on the negative side, -2 cubed is -8. -5 cubed, -125. So you can use this chart in your homework. Now you don't have to memorize the perfect cubes, but I do want you to know the perfect squares up through, you should already know them up through 15. Examples. Eight is a perfect cube because there's an integer that I can raise to the 3rd power, or I can multiply it by itself 3 times to get 8. And that integer is 2. 2 is called the cube root. And -8 is also a perfect cube. Because I could put in an integer here, -2, and cube it, and I could get -8. Now they're called perfect cubes because there exists a cube that has a volume of that number. So for example, the perfect cube of 8 has a volume of 8, and it would have whole number side lengths. So in this case, it would be 2. 2 times 2 times 2. Because if you remember, volume is length times width times height. So that would be a perfect cube. So I want to compare, am I off? Can you still see this? Oops. There you go. You weren't able to see that. On this one, so negative 2 cubed is negative 8, and negative 8 is a perfect cube. Now I want to compare square roots and cube roots. Because they're pretty simple until you start mixing up the questions with squares and cubes and square roots and cube roots. And that's when people start getting confused. So I'm going to make 2 columns. And the first type of question that might be asked for this is going to be the square side. What are the square roots, plural, of? And as far as the cube root side, it would just say find the cube root of, maybe. So A. 25. What are the square roots of 25? Well, 5 and negative 5. Because if I square each of them, I'm still going to get a positive 25. Find the cube root, no S on there because a number only has one cube root. Find the cube root of 27. That's 3. Because 3 times 3 times 3 equals 27. B, let's do a fraction. 81 over 100. What are the square roots of 81 hundredths? Well, you take the square root of the top and the square root of the bottom separately and put them together. So that would be 9/10, and then there's negative 9/10 too. Whereas on the cube side, if I have, for example, 1/8, the cube root, looking at the top and bottom separately, cube root of 1 is 1, cube root of 8 is 2, so I get 1/2. So that would be the answer. Let's see, let me go back and box these. Only one answer, not a positive and a negative for the cube roots. If I say negative 49, what are the square roots of? You would say does not exist. Because you can't take the square root of a negative number. There's no number times itself that gives you a negative 49. And if you say negative 7 times 7, that does give you negative 49, but those are 2 different numbers, not the same number times itself. If I gave a negative problem for the cube root, though, that's okay. Negative 4 is the cube root of negative 64. So if you look back in the table here, there's negative 4. Its cube root is negative 64. And this one, I'm going to continue my chart here. On D, this is a different kind of problem. This would just say find, and then it uses the square root symbol. That symbol means the positive root only. So you would only say 3, not negative 3. The cube root symbol is similar. So if I put 729 and I want the cube root of it, but I'm using the symbol, not words. The cube root of 729, see it has a little 3 here, is just 9. Go back and box my answers. And E, see if I make sure I'm still on visible here. Yeah, okay. E, find, using the square root sign, negative 25. This is not possible, or does not exist, because you can't take the square root of a negative. But if I put a negative under a cube root, -1, let's make it easy. That's okay, because because there is a number when multiplied by itself 3 times gives you -1, and that is -1. Because -1 times -1 times -1 does equal -1. 3 negatives is odd. It's an odd number, and that makes a negative answer. So I'm going to show you, let's see, I'm going to turn this over, show you how to solve square and cube root equations. The cube root equations are part of section 1.3. The square root ones I'm adding. And cube root equations. So let's start with the cube root, because they're actually a little easier. Cube root equations. Example 1. X cubed equals 8. You want to solve for x, and you could just look at it and say, yeah, that's got to be 2, because 2 cubed is 8. But there are certain steps that I want you to show to get you in the practice of showing your work when you solve equations. Because down the road, solving equations, there's going to be a lot more steps, and you really need to show your work. So your first step to get x alone is to undo this cube. And a cube root cancels a cube. They undo each other. That's how I'm going to get x by itself. But if I cube root the left side, I have to also cube root the right side, so my equation stays balanced. Now these two cancel out, and I just have the number I started with, which is x, equals the cube root of 8 is 2. Box or circle your answer, and then you have to check. So go back to your original equation, put a parenthesis where the x is, and plug in your answer, 2. Make sure that this really does equal 8. Don't try to fake your checks. And you've got to write this step, 8 equals 8, because it's almost like a proof we're doing. Example 2. X cubed equals negative 216. All right, we need to solve for x. We need to get x alone. So to undo the cube, I need to take the cube root, but I have to do it to both sides, so we stay balanced. Negative 216. You have to show me this step just like this. X equals, now the cube root of negative 216 is a negative 6. Box or circle the answer, check. Go back to the original equation, put a parenthesis where the x was, plug in your answer, and then look at it and make sure that negative 3 cubed is negative 216, and you can check the chart. It does work out. Negative 216 equals negative 216. I'm going to, just so I don't run out of tape, because I only have a few minutes left, I'm going to do a square root equation now. So square root equations. Example 1. X squared equals 16. Well, we need to get x alone. We know that it's, well, we know at least one of the answers by looking at it, obviously. But to get x alone, we need to undo this square. So we need to take the square root to cancel it. I need to do it to both sides. But when you take the square root of the other side, and this only happens when it's a square root you're using to solve the equation, you have to add a plus minus, because really there's two square roots and you need to have this on the other side. So whenever you take the square root of an x squared, you need to have a plus minus on the other side. Now this just goes to x. This becomes a plus negative 4, which means there's two answers. There's positive 4 and negative 4. And that makes sense because 16 has two square roots. It has a positive square root and a negative square root. Now when you check, I know this is annoying to people, but you have to check both solutions. Down the road when these get more complex, the check can really save you. So go back to the original equation, put a parenthesis in place of your x, plug in, I'll do the positive one first. 4 squared really is 16, so that checks out. Now go and test the negative solution in the original equation. Well, negative 4 squared is positive 16. So they both check out. One more square root example. Let's do x squared equals 169. Take the square root of both sides. Don't forget the plus minus on the right side or the other side from your variable. X equals plus negative 13. Two answers, positive 13 and negative 13. Check both. Original equation. Put in the positive 13. 13 squared is 169. That checks out. And I'm going to go over here. Let's put in the negative 13. Square it. This really is 169. So they both check out. Now, really quick, I just want to show you this. If you see an equation that's like x squared equals, say, negative 4. If you can recognize it here, you could say no solution, because there's no number squared that gives you negative 4. If you don't recognize it here, you go to the first step, take the square root of both sides. This is a plus minus. And you should see that, you should recognize the negative under the square root. That should be a red flag. You can't have that. This makes an imaginary number. So there's nothing really to be done. You can't solve it, you can't check it, it's no solution.